Okay, so today we're going to look at free fall and acceleration. So last time at the end of class, you watched a video of a hammer and a feather being dropped from the moon, and you saw that they both fell at the same time. Okay, and then we said that was an example of free fall, so things falling only due to gravity. So by definition, if an object is in free fall, in the vertical direction, the acceleration is due to gravity. So what that means is that the only thing that's making the object speed up or slow down is gravity. Okay. A thing about it is, though, is that an object doesn't technically have to be falling to be in quote unquote free fall. So when you throw a ball up and it leaves your hand, there's no other things acting on it other than gravity. So it's in the air, the ball goes up, the ball comes back down. Why? Because of gravity. So that's what we're talking about in terms of free fall. It doesn't necessarily mean that the object is always going down. It just means that the only acceleration or the only force that's acting on it is gravity. So anytime you have an object in free fall, your acceleration in the vertical direction is going to be gravity, which we can write that instead of saying AY. So remember, A is your acceleration, Y talking about the vertical direction. We can say that your acceleration would be G. And gravity here on Earth is negative 9.8 meters per second squared. Okay, this is an average. Gravity changes a little bit depending upon your elevation. So you'll see 9.81, 9.812, 9.05, things like that. So we're just going to use 9.8. I think on the online homework they tell you to use 9.81, so just be careful with that. But for us, it's 9.8. The negative is telling you that it always acts downward. Gravity never works up. It is always pulling things down. So a couple things about free fall. The first thing is that it never ceases to exist. So gravity is always there. Okay, when you're working on problems, it's a given. Just write it down. It always works down. So gravity is never going to be positive. It's always going to work down. Okay. If you're in free fall, your acceleration is never zero. Even at the top of the throw, when the ball stops for a split second, gravity is still acting on it. Okay, it's just changing directions. If you think back to a velocity versus time graph of something in free fall, it would be a straight diagonal line. Excuse me. So it would be starting up here at the top, and it would be slowing down, slowing down, slowing down. Remember, as you pass the x-axis, that's where you're going to stop for a brief moment as you're changing directions, and then you're going to speed up on the way down. So when you throw a ball, it's going to slow down, slow down, slow down, slow down, change directions, and then speed up on the way down. Okay, so your velocity is going to be positive on the way up. Since you're traveling north, on the way down it's going to be south, which is why it's negative. And if you look at the slope of that line, it would be negative 9.8 meters per second squared, because remember, the slope of a velocity versus time graph is your acceleration. And lastly, this is only true in a vacuum, so something that there's no air resistance. The nice thing about it is, for y'all, is that all of our examples, we're assuming everything is in a vacuum. There's no air resistance, so just keep that in mind. Alright, so kind of like what I just said. So you throw a ball straight upwards into the air. Excuse me. What is the acceleration at the top of its path? So this would be in its highest point. So the ball, it goes up, comes back down. So when it's at the very, very top, okay, that's going to be negative 9.8 meters per second squared. Okay, what is the velocity? So at this very top point, what's your speed? That's where you cross the x-axis. So your velocity would be 0 at that moment. You can label it V0, you can label it VF. It just depends upon which way are you starting and ending it. So if you're on the way up, then your final velocity at the top would be 0. If you're going on the way down, then your initial velocity would be 0. and your final velocity would be some other number. What is the magnitude, the value? Anytime you see the word magnitude, it just means numerical value. You're going to see magnitude like a million times this year. So magnitude just means number. So what is the magnitude and the direction of the acceleration halfway up? Gravity, negative 9.8 meters per second squared. What is the magnitude and the direction of the acceleration when it's on the way down? Still gravity acting on it, so still negative 9.8 meters per second squared. So the moral of the story is that when you're in free fall, your acceleration at every single moment in time is negative 9.8 meters per second squared, which is your acceleration due to gravity. Okay, and again, this is valid for every single situation that you can come up with, unless you're throwing in air resistance, which we will not do. Okay, so we kind of live in our own little physics world, and we do not include air resistance with it. All right, so look at your homework, and we're going to go through number 47. So 47 says, a stone is thrown vertically upwards with an initial velocity of 25.4 meters per second. How high does the stone rise above the thrower? And then what two times will it be 7.6 meters above the thrower? So start writing down your givens. So we have an initial velocity of 25.4 meters per second. We have a final velocity, since it says how high will the stone rise. So you're talking about at the top of the path. So when you're at the very top, your velocity is 0. Okay, your initial velocity is going to be positive since you're throwing the stone upwards. And then you know your acceleration is gravity, negative 9.8 meters per second squared. And then you're looking for how high it went. So you're looking for a distance, which is delta y. So I'm going to use y since you're talking about height. Height is always in the vertical direction, so delta y. So you're going to look back at your amigos to see which equation has v naught, vf, a, and delta y in it. And that would be your third amigo, which would be vf squared equals v naught squared plus 2a delta y in this case instead of delta x, since you're talking about the vertical direction. So solve it for delta y. Vf squared minus v naught squared equals 2a delta y. Sorry, I messed up for a second. Y'all can go ahead and keep going. So Vf squared minus Vo squared over 2a equals delta y, and then plug in and solve. Be careful with your negatives. Your negatives will end up canceling out since you're just going to square the 25.4. So then you have a 0 minus that answer over 2 times negative 9.8. So you'll get a negative over a negative, which will turn into a positive. And that should give you 32.92 meters. Okay, so that's how high it went, was 32 meters. Almost 33 meters. All right, part B. I'm going to open this one up on a new page because part B is pretty long. Part B, you're solving for the time. And you're looking for the time when it's at 7.6 meters. Again, you're still talking about throwing a ball, so your acceleration is still negative 9.8 meters per second squared. And you know you have an initial velocity of 25.4 meters per second. Alright, so here's the thing. There's multiple ways to do this. One of them involves the quadratic equation. One of them does not. Okay, so it is your choice. I'm going to go the route that does not involve the quadratic equation. It doesn't matter to me. So if you want to use the quadratic equation, you can. I'll show you just like the setup for it. So if you want to use the quadratic equation, you'd be using the second amigo, which would be delta y equals v naught t plus 1/2 at squared. You would be solving for time, which is why you have to use the quadratic. So you would end up with 0 equals negative delta y plus v naught t plus 1/2 at squared. Okay, so now you can kind of see where the quadratic equation comes in from. Your delta y, you would plug in 7.6. Your v naught, you would plug in as 25.4. T would obviously be what you're solving for. And then your acceleration is that negative 9.8 meters per second squared. Okay, so you would go through, use the quadratic equation. You want 2 times, so that means both of your answers that you would get from the quadratic equation would be your 2 answers. So it's unlike other problems where you would have to try and figure out which answer from the quadratic makes the most sense. In this case, you wouldn't have to. Both answers would make sense as long as they're both positive. So that'll tell you if you did it right or wrong. I'm not going to go that route. I'm going to go the other route and show you how to do it if you don't want to use the quadratic. Most of the time, there's another option. There's not always, but sometimes you may end up having to use the quadratic. It's just up to you. So what I'm going to say is that I'm going to figure out how fast we're traveling at the 7.6 meters. Okay, so you're throwing a ball. It goes up and it comes back down. You know this total height from the previous problem was 32.92 meters. So I'm just going to use it though here as like my stopping point at 7.6. So I'm going to solve for how fast I'm going to travel at this point on the way up and how fast I'm going to travel at that point on the way down. So what I'm going to say is that I'm going to solve for my final velocity. To do that, I'm going to use the third amigo since I don't know at what time frame I'll be at 7.6 seconds or 7.6 meters. Apparently I can't write today. 2a delta y. So this means my final velocity is going to be the square root of VO squared plus 2a delta y, and then plug it in. So I have 25.4 squared plus, and then 2 times negative 9.8 times 7.6. Then take the square root of that whole thing. And I'm going to get a velocity of 22.28 meters per second. Now remember, when you're doing the square root of something, your answer can both be positive or both be negative. So I have this plus or minus factor in there. So what that means is that when I'm at 7.6 meters on the way up, my velocity at that point is going to be positive 22.28 meters per second. And on the way down, my velocity at that point is going to be negative 22.28 meters per second. So here's an important thing that you should add in your notes. At equal heights, you have equal velocities, or equal speeds. Your velocities are going to be different because they have different signs. So equal heights are equal speeds, because on the way up, gravity is slowing you down. On the way down, gravity is speeding you up. Gravity works the same on you regardless of whether you're going up or down. It's always that negative 9.8 meters per second squared. So that means when you're passing the same point, you're going to have the same speed. Just on the way up, it's going to be positive since you're heading north, and on the way down, it's going to be negative since you're heading south. Since I have that number, now I can go in and use a different amigo to find my time. So I'm going to work that out over here on the side so y'all can see it. So to find my time, I can now use the first amigo and say VF equals VO plus AT. So VF minus VO equals AT. So VF minus V naught equals AT, or equal over A equals T. Maybe if my pen will erase, as my computer just froze. So you should have VF minus V naught over A equals T. Which will turn into your equation that you can plug and chug in. So then this is 22.28 minus 25.4 over negative 9.8. That will give you one of your times. And then the second time you'll do it, so when you do it this way, you'll get T equals 0.32 seconds. Then you'll do it again using the exact same equation, only now you'll make your initial velocity negative, or your final velocity negative. And you'll get a time of 4.87 seconds. So you'll do it once, leaving your final velocity positive, once with your final velocity negative, to account for your two time frames. Once when you're going up, once when you're going down. You're going to want to keep your initial velocity as positive 25.4, since you're wanting to know the total time frame from the beginning. If you changed your velocity to a 0 or something like that, you would be noting like how long it takes to go down from the highest point, which that's not what the question is asking for. It wants the total time from when it leaves your hand till it passes that point on the way up and the way down. Okay, so you can solve it that way as well. Right. Now look at 48s. Okay, I promise not all of them are that long and that complicated. So 48 says a robber drops a bag of loot into a 30-meter deep well. If the speed of sound is 30 meters per second, how long after dropping the bag does he hear the splash? Okay. So again, you're talking, it's going down and then it's coming back up. Okay, so they tell you that the well is 30 meters deep. So that's going to be my delta Y is 30 meters. On the way down, my acceleration is negative 9.8 meters per second squared. And since it says that the robber drops it, my initial velocity is going to be 0. Okay, so what I can do first, because on the way up, sound doesn't travel in free fall. Sound travels at its own speed. It travels at a constant velocity. So as you're sitting there talking to someone, your speed is, the sound is not moving faster and faster. It's moving at a constant speed as long as it's through air. So what we're going to do is we're going to solve for the time on the way down, so T1. Then we're going to do the same thing and find the time on the way up. And on the way up, we're looking at sound. And find, we know that the speed of sound is 340 meters per second. So then what I can do is add my two times together to figure out the total time on the way down and then the way back up. So first, to find the time on the way down, if you look at your unknowns, or your givens and your unknown, you have delta Y, acceleration, V naught, and T. So I can use the second amigo, which would be delta Y equals V naught T plus 1/2 AT squared. Your initial velocity is 0, so that means V naught T is going to cancel out, so you don't have to use the quadratic. Multiply both sides by 2 to clear out your fraction. So 2 delta Y equals AT squared. Then divide by A. So you're going to get T squared equals 2 delta Y over A. And then that's going to become square root of both sides. So T equals the square root of 2 delta Y over A, and then plug it in. Remember, delta Y is a vector, so your direction matters. So that 30, in the first instance, you're going down, so it's actually a negative 30 over negative 9.8 meters per second squared, which is your acceleration. So that's why your negatives will end up canceling out. It's a negative over a negative. So your first time ends up being 2.47 seconds. Then for the second one, since you're moving at a constant velocity, you can go back and use your constant velocity equation, which is V equals delta X over T. Again, you're going to solve for time. I'm also going to change it, instead of saying X, I'm going to change it to Y, just since we're working in the vertical direction. So then this is going to be TV equals delta Y. So then T is going to be delta Y over V. Your delta Y now is on the way up, so that means that that 30 is positive and your velocity is 340. So your time on the way up is going to be 0.09 seconds. So then my total time would be 2.47 plus 0.09, which would give me 2.56 seconds, which is my final answer. Okay, so since you have to separate it out, since you have two different situations going on. In the first instance, you are just using the way down due to gravity. Okay, so that's what I'm like covering here in red. That's on the way down. So you solve it once for that way. Since you have an acceleration, you have that initial velocity being 0, gravity is acting on it since it's in free fall. And then on the way up, you're moving at a constant velocity. So you have to treat them separately. Okay, you cannot use the same equations for both sides. On the way down, you're in free fall. On the way back up, you're moving at a constant velocity. All right, your homework is to do the rest of that section. So problems at 1.7 for it. Again, some of the problems are long, some of the problems are not nearly as long as others for you. And next time you're doing a lab, and then the time after that you have a test. So make sure y'all are working on these problems, getting any questions answered that you guys have, so that way y'all can get ready for your test. Make sure you have your equations memorized. I cannot stress that enough. You're not going to be given the equations, so make sure you know your equations.